Today we're at the National Manufacturing and Supply Chain Conference, where I'll be talking about whether robots will replace welders in the future. We are here today sitting and talking about steel, food and so on. We also are not getting our hands dirty. So it's just the way the world is progressing. So instead of complaining about it, we just have to find a solution to the problem. And obviously to do with the reduced amounts of skilled workforce, the cost of labor will go up, and anyone from the construction industry knows exactly what I'm talking about. So in the steel industry, there are companies who are working on sort of automating the whole fabrication process. So we've sort of looked into it. We've actually even contemplated applying for a grant to work on a robotic assembly line. But then because I've done some research and I saw there are companies who have already done a lot of progress, I thought to myself, well, why compete if we can think of what's next, what's beyond automated fabrication? And that is why the obvious sort of answer was to focus on 3D printing, because if there's anything that will replace automated fabrication, will be robots doing the work, not by attaching existing components together, but by actually printing them. So we've partnered up with quite a few strong partners. I would say the lead partner is Foster & Partners. We're working with Imperial College, Cranfield, also Warwick University and Bath University, and a few other partners. And we are, we've applied and the result will be next Friday, so hopefully we are successful. And the whole grant is about introducing 3D printing in structural steel. So 3D printing of steel obviously has been done before, but it's normally from powder, but this is about large, heavy sections. We started off our whole project with Cranfield University. We've sponsored a master's degree just to sort of get the ball rolling to check whether 3D printing of steel is actually possible. And 3D printing of steel is nothing different than having a welding torch attached to a robot, and basically the robot just follows the paths that are programmed. And it does it so layer by layer, similar to any other plastic or food that we've just seen. So this was our project. It was to print an end plate onto an existing beam, and I will sort of hand this out. Please just put it around the audience. So this is one of the samples. I think there were like 30-something of them printed with different parameters. I know you might say that this looks very industrial and so on, and yes, I agree. But always, because I come from the aviation industry, I always compare today's A380s to the Wright brothers plane. So obviously we've made significant progress over the last 100 years, and the same as with 3D printing. Like with the food, these are the early days. It will progress, it will become faster and cheaper, and it'll be just, the adoption will be much broader. So this is the close-up, but you'll have it in your hands. Here are some parameters. All in all, I think it's worth noting that it takes around 3 hours to print this kind of connection. It might sound a lot, but then we'll do some financial analysis and it will be quite surprising. Obviously, it wasn't straightforward. There were a lot of issues that were we had to overcome. It's a bit of lack of fusion, and it was very interesting at how sensitive the whole process was when it came to the angle of the torch. So there was a lot of trial and error. Even though Cranfield is very experienced in 3D printing, it still took them some time to actually get the parameters right. There was a question whether you can take a photo of this sample. Feel free to take a photo. We can also have a selfie together afterwards if that's something you want. So these are the parameters used. And this is the cost analysis. Now, a used robot, and for this kind of work, we don't need a fancy new robot. We can use a used one. The cost is £20,000, and the lifespan is roughly 3 years. So this is a one-off cost. Now, if we employ a human welder, roughly speaking, the wages would be around £40,000 per annum. If we want to cover 3 shifts, then we have to pay triple the amount. And if we look at it over 3 years, then we have to multiply that by 3 again. Now, if we divide these totals by the amount of days in the 3 years and then hours in a day, it turns out that the cost per hour is significantly lower than the human welder. So even if the process takes 3 hours compared to around 15 minutes for a human, the cost is a bit lower. Now, obviously, there are many other variables. You could say that actually a robot just doesn't work on its own. You need an operator to just overlook it. But then also a human welder doesn't weld 8 hours a day without any issues, without going to the toilet, without having a break, and so on. And also a human welder does need some fabrication drawings that are prepared by an engineer. So it's comparable to having an engineer programming the robot. So even if the figures are comparable, that gives us the green light that actually there's a lot of scope to actually do some more research, because the more we progress with the process, the price will go down. And obviously, as I mentioned, we're not the first ones to print in steel. This is from powder bed. It is being used now in the aviation industry. Formula One uses it as well. This is Arup's approach at printing a node. It was very expensive and I don't think it was adopted. And also, like I gave the example with the planes, it's like with Formula One. 30 years ago, the front wing was just a wing, straight profile, whereas now it is all curved and all these fancy shapes, which is obviously all designed using computers. So same as with 3D printing, the more we work on it, the more advanced and the more progress we'll make. So this is a few samples from Foster & Partners. This is our idea, is to make 3D printing a feature. At the moment, steelwork is hidden, so the steelwork is behind the cladding here, and even if it is exposed, it is painted in the color so that no one sees it. So we want to change it, and we want steelwork to become a feature so that everyone will be proud of Connection, so you can actually show off or have it as a feature in a building. So this is an example, although I'm not saying that this is very pretty, it's just our first approach at optimizing the connection in terms of weight or material used for this connection. This is another approach. Photo's a bit too bright, but this is a typical Glulam connection. So you have massive timber joists connecting to each other, and you need a steel plate. So again, we've done some optimization, and we've came up, probably this is the most optimum shape. We would need an architect or a designer now to do their work to make it look really pretty. So my answer is yes, the future is only with robots. It's not a matter of if they will replace welders, it's only a matter of when. And the way I see it, I could see two ways. One is having robots printing the whole entire structure as just going beam by beam, and it wouldn't be the way we do it now where we just have like an I or H section. It will be a very optimized shape like the front wing of a Formula One vehicle. Or the other option would be a hybrid method where we use the main members from the mill like they are now, but have robots to weld the connections on site. So that is the way I see it. I'm pretty sure I will be still alive when this happens, and hopefully it will be us who actually implement the new way of building steel structures. So as I mentioned, our goal is to revolutionize the steel industry, so it's not only 3D printing that we focus on. We've also looked at, or still looking at, artificial intelligence for quoting. So basically to use computers to sort of highlight steelwork automatically and then export it.